All right, number 7. Sorry about the small pictures. Just got to do this to get the whole thing in there. Number 7, complete the following table. And so we start with the formula H2S. Now, when I draw my Lewis structure, which you should already have, right, I have 2 hydrogens bonded to the central sulfur, but the sulfur has 2 lone pairs of electrons, 2 unshared pairs of electrons. That is going to push the bonding angle of these 2 hydrogens down. It's going to make the geometry bent. Now, is it polar? Yes. I can definitely tell that the top half of this structure is going to be partially negative, and the bottom part is going to be partially positive. Cl4. Yeah, that's carbon tetrachloride. I have my central carbon. I have 4 chlorines spread out around it. All right, that has the AB4 format. That's going to be tetrahedral. Is it going to be polar? No. All of these things are spread out evenly, all spread out evenly. So even if this individual bond is polar, it's going to be offset by this bond. If this bond is polar, it's going to be offset by this bond. So there's no overall polarity. BF3 is going to be under the category of AB3. All right, so I have my central boron, my 3 fluorines around it. Okay, this is going to be trigonal planar, because there are no lone pairs or unshared pairs of electrons around the boron that would push the boron-fluorine bonds down, as we see up here in the first example. That doesn't happen. So this is trigonal, because there are 3 atoms here. Trigonal, planar, because it's flat. Okay, nothing is being pushed down because of lone pairs. H2O. This is going to be the exact same thing as H2S. And it's actually pretty easy to guess that, because what element is right underneath oxygen on the periodic table? It's sulfur. So it has the same number of valence electrons. It has the same number of valence electrons. So it's going to have the same number of lone pairs around it if it's going to bond with 2 hydrogens. It's going to be bent, and it's going to be polar. It's going to have a partial negative side up here, partial positive side down here. PCl5. We have our central phosphorus, then I spread out my 5 chlorines around it. Okay, spread out, spread out, spread out. Even if there's going to be polarity in these bonds, which I don't believe there is, let's go double check. We got phosphorus and chlorine. Actually, no, that's 0.9. That's a 0.9 difference. Those are going to be individually polar. But what's going to happen here is we have these 3, right, trigonal. We have these 3 atoms spread out around in a triangle around our central atom. Then we have a chlorine that pops up and a chlorine that pops down. And so even though each of these individual bonds are polar, they are neutralized, they're balanced out, because each of these chlorines is successfully spread out as much as it possibly can be, and there are no lone pairs. So the geometry is going to be trigonal bipyramidal, but it's not going to be polar. BF2, so we have a central beryllium and 2 fluorines on the side. This is going to be linear. Why is this linear and not bent like we saw in these previous 2 examples? Because beryllium doesn't bring any lone pairs, doesn't bring any unshared pairs of electrons to the table. Because of that, there's going to be nothing to repel the electrons within these bonds to push them down at a lower angle. So it's going to be linear, and it's not going to be polar, because these polar bonds are completely offset by each other. They're opposite in orientation. Let's finish up with SF6. We have our central sulfur, and sulfur is bringing 6 valence electrons to the table. So we're going to force sulfur to form 6 bonds, each to 1 fluorine, and we are going to spread these out as well as we can. We're going to have 4 fluorines spread out across kind of like the waistband of this sulfur in one plane. Then we're going to have 1 fluorine go up, 1 fluorine go down, and that's going to create 2 separate tetrahedrons, one on top, one on bottom. All right, so that's 2 separate 4-sided figures. One's right side up, one's upside down. So if we have 2 4-sided figures, that totals 8. So this is called an octahedral. And because we successfully spread out this number of fluorines, and there are no lone pairs of electrons around the central sulfur, this is not polar.